So we've got our spine stretch set up. Now let's look at the squash. So what we want to achieve is essentially when our spine stretches and squashes, the volume of the visible volume of the object appears to equalize so that it seems to maintain its mass. And we're using scale X on the joints to drive our length or the stretch value. So in order to drive the squash, we're going to need to get some information and pipe it into the Y and Z axes of each joint so that again they scale equally in the opposite direction. So before we do that, one thing I do want to set up is I want to just temporarily skin our geometry to the spine. That way we can visually see on the mesh how our stretch is currently affecting the geometry, which is important to see. So in order to achieve that, we're going to select the geometry and select the entire chain of joints for the spine, which starts here at the hip. So I'm going to open that up, select hip through spine 3, and then I lost my geo selection, so I'm going to add those back again. And then I'm going to go up into the rigging skin menu and do a bind skin operation with the geodesic voxel bind method, and the max number of influence is set to 3. Everything else I'm just going to leave at the default. Run the skin, and now if I test my stretch, you can see Batman is definitely stretching along with the spine, but again there's no volume correction, especially you'll notice that mostly when I squash him. When I squash him, he does not get wider. The width stays essentially the same. Ignore the fact that his legs and head are squashing and stretching too. Once those joints are included in the skin, that won't happen anymore. So how do we fix that? Quite simply, I'm just going to zero this back out. We're going to use more math nodes, just like we did in our equation to figure out what the stretch should be. We're going to take the result of the information from the stretch and then modify it and plug it back into the squash or the YZ values. So I'm going to open up my node editor, and here's what I've previously done. We will need to use some of this information again, so I'm just going to kind of move that up. And we are going to need another math node. Actually, we're going to need 2, so I will create those right away. So I'm going to need 2 multiply divide nodes. So I'm just going to duplicate them with this, which is Control D. Now, the first thing we're going to need to calculate is the square root of the current spine length percentage value. That will give us the appropriate amount of scale that we need for the Y and Z values. However, we'll be missing one bit of information, and we'll deal with that when we get there. So let's just go ahead and isolate and solve the square root problem. So to get started, we need to take the output from the previous multiply divide node, which is the one that we've labeled spline length percentage division. So it's going to be that percentage value. I'm going to take that and plug it into the input 1x of our new multiply divide node. And then in the settings, we're going to change the operation over to power, which is how we find the square root. And in Maya, or with the multiply divide node in Maya, you always, to find square root, you always switch the operation to power, plug your value into input 1, whatever that's going to be. In this case, it's the spine length. And input 2 is going to be 0.5. So again, square root is always going to be power x over 0.5. So that should give us what we need. Definitely label it So just following the same rules as I did before, this one is going to be named based on what it's doing. So spline underscore length underscore percent underscore square root, SQRT. So the square root of the spine length percentage, and I'm using a power operator, so underscore pow. So again, based on what it's doing and the operation that it's using to do it. So with that labeled, and actually the information we need already plugged in, I'm gonna select it, hit the 3 key to open it up. Oops, accidentally. Accidentally cleared the graph of my other information, so I'm going to have to bring it back again. So I'm going to select my bones, that's essentially what I need, and drag that back in. There we go. And same as before, we don't need to plug it into spine 3, but we do need to plug it into the other 4 bones. So it's going to be output X, this time plugged into scale X and Y. Now if you don't see them, again, just open up the graph for each of them. So I'm going to shift click, hit the 2 key to open them up enough to get scale exposed, and then open the scale rollout so I can see all the values, and we'll try that connection again. So output X into scale Y and scale Z for each of them. There we go. Now if you want, once you've got them connected, you can hit this button here, which will clean up your graph, so it'll just kind of rearrange everything so it's a little bit neater. And let's see what those changes that we just made, let's see how they affect the animation. So we'll take Batman again, and we'll do the same test we did before. And again, you can see now he is scaling, but the squash and stretch value is not doing what we would expect it to. Now when I squash or shrink the spine, in a proper squash stretch relationship, the volume should be getting larger, or the width and depth of the character should be getting larger to compensate for the reduction in the height, and that's not happening. So essentially they're in sync as opposed to opposing each other, and really the XY value should be moving in the opposite direction of the YZ value should be moving in the opposite direction of the X value. So that's what our final multiply divide node is going to achieve. I'm going to put that back at the default, back to my node editor, and I'm going to create that multiply divide node again, because I accidentally cleared it out. So because this one isn't doing quite what we wanted to, we can actually delete the current connection. So I'm just going to drag a box around the outputs from my square root multiply divide node, and I'm going to put this one in place and plug it in. Now, just like the others, we are going to take the current value that we have from our last node and pipe it into the new one, but this time, because of what we're about to do, we're going to plug this one into input 2x instead of 1x. So it's very important to make sure you put this one into input 2x. I'm going to double click on it. So what we're going to do with this one, we need the inverse of the current value, the inverse of our square root value. And mathematically, all we have to do is divide 1 by our value. So in this case, input 2. And if you divide 1 by any number, the result is going to be the inverse of that number. So now that I've got this inverse, I'm going to label it. So spline underscore length square root underscore INV for inverse underscore DIV for division. So spelled spline incorrectly. So it's spline length square root inverse, and it's calculated by using a division operator. Now, same thing as the others. Once we've got that done, we just plug it back into the y and z values for the previous bones. Still output x, by the way. That's that one. There we go. It's the last one, so I'm going to minimize that and check it out one more time. So now we're going to grab our test object, and now we can see, because we've got that inverse equation in there, now we see we're getting proper squash and stretch, which is exactly what I'm looking for. So I'm going to zero that out once again, and then back where I started. And that pretty much concludes this lesson. So we took the another multiply divide node, used it to find the square root of the scale percentage or the length percentage value of the previous multiply divide node, and then we used a third one to calculate the inverse. And then with that information, we're able to pipe that into our y and z scale to give us the correct amount of opposing scale to compensate for the value of the x. So that also concludes our torso setup. The last step for this would be just to create our neck controllers and head controllers and graph that into our spine to finalize that. So we're going to do that in the next video.